In intrusion detection system and intrusion prevention system, we'll go through the concept and see what is the difference between them. This is what actually will matter for us for the data-driven cybersecurity. The previous devices that we discussed about firewall, network access, and VPNs can give you information about a log or what's happening. Here, it's the first helpers that can actually point us and point our data towards the critical parts. Whenever there's an intrusion detected or an intrusion about to happen, or the system try to prevent this intrusion. And this is where we use the IDS and IPS. This is your best friends for data-driven cybersecurity. And the definition of the IPS and IDS can go as follows. Intrusion detection system and intrusion prevention system are both part of the network infrastructure, and they are devices or the software entities that compare network traffic or network packets to a Cypress thread database containing unknown source and destination, but known signature inside the cyber attack, and they can flag them by any matching of the packet. There's a whole course about IPS and IDS. We need to know that they can be signature-based or anomaly-based detection. They can be a host-based or network-based systems, and the difference between them are discussed in other courses. So I will advise you strongly to go back and read about the IPS IDS if you need to refresh your memory. But generally, it's a small device that can be attached right to the firewall or right to the different networks to get an idea what's going on inside the network, to protect it from any known threats. And a fast difference between intrusion detection system and intrusion prevention system is that the IDS will be parallel to the traffic, just listens to what happens and just tells you, oh, you know, there was an attack. Yeah, good luck with that, something like that. But IPS will be a resident on the traffic itself. It will go through every traffic that want to go in and out, have to pass through it. And this is how it can prevent an attack. Both of them are very adjacent to the firewall. Some of them can be in the DMZ zone, or they can be really attached to the firewall. Cisco system have a module of IPS that you can actually insert inside the router with the firewall. So this can be given even you a better capabilities of the IPS. And this table shows you the difference between the IPS and IDS in more written form. But the concept that I want you to know, just one of them can resident parallel to the traffic, and the IPS have to be within the traffic. All the traffic have to pass through the IPS, and this is the main difference that I want you all to take care about. Okay. Sometimes I can draw the IPS and IDS in this form to show you what is the differences and what is the similarity, and this actually summarize whatever we were discussing before. There's a lot of products that can provide you IDS and IPS. For example, Cisco, Jupiter, Sunnywall, Barricada, and a lot of them. I just listed the most popular product, but there's much more than this. The next we'll be talking about network security monitoring. Actually, I have a whole course that I teach in network security monitoring. So if you took this class with me, you will be very familiar with what we are discussing. So it's just a small refreshment of this beautiful subject. If not, you will get a good introduction that I want to tell you the importance of the network security monitoring. It doesn't matter how strong or secure your system. If you don't monitor what's going on inside, it will fail. If you have the best firewalls, the best IDS and IPS and everything, if you don't monitor the traffic, what is the purpose, right? So the network security monitoring is a system that have collection, detection, and analysis of your entire activity and try to protect the network and actually improve your network while you are using it. As we said, your best friends are the IPS and IDS. Network security monitoring solutions are the best for alerts because they can collect the data and alert you for whatever happens inside. And whenever we go and look at the additional parts of the network security system. We have to take care of the model definitions and the creation of the strategy and track the progress, and can happen with the network security monitoring. For example, this definition of security monitoring is based upon the collection of data to perform detection and analysis. With a collection of large amount of data, it makes sense that the SOC should have an ability to generate statistical data using the existing data to reduce the amount of sample space of the data that we have, as well as doing some statistical analysis for the detection. We will use this concept starting from here and move on with our data analysis to see what we can do with this data. Because at the end of the day, any network security monitoring device is actually based on alerts and collected data. Whenever it goes to analysis, they become very weaker because they want to spend most of the time and resources in collecting and monitoring the traffic. But if we look at the cybersecurity from the data point of view, we can start from here and get a almost ready data for us to continue our next steps. An example of network monitoring is just a combination between network monitoring and security monitoring together. One of them to prevent downtime, the other one to protect the data. And the goal to keep the business running. This is why we have network security monitoring. Example of the process, you can have a different entities, you can get the raw data, you can sample alerts, you see the warning and the incidents, filter them and make a knowledge base that you can use for monitoring. And out of it, we can start our data-driven cybersecurity. Simply application or architecture of the network security monitoring, you just put something called nodes. Nodes is small devices, but very strong processing power and space. You can put this small sensor within your network, usually one device per sublane or something like that, or you can, the minimum is to use one per router or per network. These devices will collect the data in different spectrum and different consolidation of the data and try to detect or alert you if something happens. As you can see, the only problem here is you need a lot of space to store all this traffic. Imagine you storing every single communication on the network. It's crazy. It can go to 3 terabytes per day per machine or something like that. So you need to make sure that you have enough space. And using this and using the data-driven cybersecurity, we'll try to look at this data and try to minimize it, to use only the ones that really need it for us, using statistical data, big data analysis, and machine learning. And this is why we now just putting the base for where we get the data. And we just remember that the network security monitoring, it based on the life cycle is based on 3 parts: collection, detection, and analysis. Definition is very simple: to collect the data, to look at the event, and to make it human interpretable data for analysis and alerts. A lot of classification, you can use just level 1, level 2, level 3, but all of that is discussed in the network security monitoring course. But what I want you to know is this simple terms and definition of that. What does the asset mean? What is the threat? What is the vulnerability? Exploit. What is the meaning of the risk and the incident? Anomaly, what it is. Yes, knowing this terminology, it will be easier for you to follow with any talk about network security and data-driven cybersecurity. There's a lot of examples of the network security monitoring system. Some of them have very beautiful view for analysis, some of them very fancy. As you can see, it's almost like the slides theme that we have anyway. And some of them are free and open source. I usually use the Security Onion package for the classes. It's very interesting to use, but it needs a lot of experience to install it for the first time. Next, we'll talk about the vulnerability management system, which actually is the process of identifying, evaluating, and treating and reporting of the security vulnerability in the system and software that runs on them. Because usually you can have vulnerability not from the pure design, but a lazy system administrator forget to close a port or open a port, forget a feature that is not needed, forget to make an update or security update that is critical and they forget to put it there. Misconfiguration usually very limited, but wrong configuration is more famous in this area. It's why we need the vulnerability management system. So it can identify, it can evaluate, it can make treating and make reporting. So it's not an entry data. No, it's only the management of the vulnerability, what to do next. And the life cycle of any vulnerability system can go with like that. You have assets, you have priority of assets, what action you need to do, what is the releases that you need to add, what is the improvement needs to be done, and again to the assets and so on. And this is how you get the cycle. Also, they sometimes write it in this way to identify, to protect, detect, response, and recover. And this is the life cycle of your network vulnerability management system. Some example of the common vulnerability of the management system is something called Common Vulnerability of Exposure. It's a website that tells you, to have like a downloaded file, tells you all the common vulnerability right now or the most recent. So make sure that you are updated to the specific point of your system. Another solution that can help you with that is Nessus, which not only can make a penetration test as we teach in our class, but actually it can give you a vulnerability explosion or the vulnerability management system for your network and give you very essential tasks not only for the network wise but also for software updates and so on. Another one was the open source is OpenVAS. I recommend you please go and look at it. You have the URL right here and you can get more information about it. The last part that we can discuss here is the security information and event management system. It is actually here, it's not a completeness for the vulnerability management system. It's an entire, it's not a data source for it even. It's an entire solution that can combine everything in the security in one point. And this is a definition for it. Just tells you it's something to make your business doesn't disturb and you can work, doesn't matter manual or automated process, day-to-day security operation centers and so on. But a better view will be in this diagram when the CM can do the data as a log collection, log analysis, event correlation, log forensics, IT compliance, application log monitoring, object access auditing. All of them will pour in one place. So you can get, after that reporting, can get a dashboard, you can have a user activity all over view, real-time alerting, file integrity, system and device log monitoring, and a log retention. Where to store the log. All of them can be in one place. So this is the modern approach of your network monitoring, network security, and analysis. However, CM is missing one thing, data analysis. And the data analysis is what we're gonna use in our course, and we'll focus on that. So what the CM gives you: visibility, manageability, correlation of events together, and it can give you automatic security event notification, as well as a comprehensive and holistic view of all what's going on in your network. In our case, we are not doing CM parallel system. No, we're using the data to come up with actions and solution, what to do next. So we're building the expert system out of it. This way, if somebody's confused, if it's similar to data-driven, no, data-driven, we collect the data and we try to come up with solution later on. But before we're getting with solution or decision making, we need to actually clean the data and really build a machine learning that can understand this data and what to do next. So we can summarize the CM in the data collection, policies, data correlation, and notifications. And here we reached our conclusion. First of all, I want you to make sure that without monitoring, it's meaningless to make anything secured. Remember, your best friend are firewall, IDS, and IPS. Collecting the data from there. This is where you get all your data to work on the data-driven cybersecurity. Vulnerability it's not only open source. It's actually a lazy administrator who didn't do his or her work. So now we have a good vision of network security, and that's all for our module 2, and see you in next module. Thank you.